Hello, this is Chemistry Central Science, 11th edition. We are in Chapter 4 on solutions, and this is the end of the chapter questions, numbers 1 and 3. So number 1 and 3 both have pictures. Will help us a little bit. Which of the following schematic drawings best describes the solution of Li2SO4? Let me rewrite it. I should have put some subscripts there for you. Li2SO4. So Li is lithium. Lithium is in group 1 on the periodic table. That means that each one of these is positive 1. Okay? There's 2 positive 1s, so this side is positive 2. It would cancel SO4, which is sulfate, and sulfate is negative 2. All right? So we want something that is going to be broken up into a negative 2 and 2 positive 1s. Does that make sense? This is negative 2. SO4 is one thing, that's negative 2. And then lithium is two things, that's both negative 1. Together, they cancel each other out. So I want something that would be 2 positive 1s and 1 negative 2. Okay. Well, it looks like the first one. Okay, because I've got a negative 2 and 2 positive 1s. But that is a herring. They're trying to confuse you. If you were to put anything that's ionic like this, remember ions are positives and negatives. Anytime that you put it in water, water is going to pull the positives and negatives away from each other. That's why when you put salt, which is ionic, sodium chloride is ionic, you put it in water, it disappears. You can't see the salt anymore. It dissociates. It breaks apart into ions. So you're never going to see positives and negatives together in water. Okay? So I need something to where it's going to be positives and negatives. All right? So let's look at B. In B, I've got 1, 2, 3, 4, 5, 6 negative 2s. Okay? 6 negative 2s and 3 positive 1s. Okay? Do you see I need twice as many positive 1s here as I have negatives. So I need twice as many. So in this case, C would be the right answer. I've got 3 negative 2s, and for every one, I'm going to have 2 positives. All right? So in that case, 4.1, C would be your best answer. All right? Number 3. Aqueous solutions, now it means in water, and in water, if it is an electrolyte, it breaks apart into ions, okay? And electricity is negative particles that are able to travel. That's electricity. So electrolyte, if it breaks apart into positives and negatives, those negatives are able to travel. In fact, in the case of a liquid, even the positives can travel. Normally in a wire, say, the electrons can travel in a wire and the protons are stuck in the wire. But in a solution, even the positives are free to move. Both of them can migrate. Okay? So if you have an electrolyte, you're going to have charges that separate. If you're going to have a non-electrolyte, okay, something that doesn't break apart into charges, like if you put sugar in water, that sugar stays as sugar. The molecule doesn't break apart, so it doesn't conduct electricity. If you were to put sugar water, it would not conduct electricity. Pure water with sugar dissolved in it wouldn't conduct it. But if you put salt in that water, it would conduct it. Okay, that's why you're never supposed to drop the hairdryer into the bathtub. Pure water wouldn't conduct electricity. But I bet you that if you have bath water, you're going to have some salt that has been dissolved, and that salt will conduct electricity and electrocute you. You don't want to do that. Please don't. Okay? So a non-electrolyte like sugar doesn't have charges. Then you have strong electrolytes and weak. Strong doesn't mean it hurts you more. It just means it completely breaks apart into charges. If it's a strong one, it completely breaks apart. If it's a weak, most of it will stay as a molecule, and then some will break apart into charges. Okay? So what do we have in A? I don't have any positives, any negatives. All right? So this is a non-electrolyte. Okay, actually I think that's a Y, electrolyte. What do we have in B? Okay, these are not charged, these are not charged, these are not charged. You have a little bit of positive, a little bit of negative. My guess is that that's weak. All right, that's a weak electrolyte. And now all of these are positives and negatives. They're completely broken apart, and so the negatives can travel in one direction, the positives can travel in another, and this is called strong. So strong means completely broken apart. Look at this one. That's not broken apart. That's what weak means. Weak doesn't mean puny. Weak means not completely broken apart, not dissociated is the word. Okay? So strong electrolyte breaks apart completely. Weak electrolytes doesn't. Okay? Not bad for 5 minutes and 57 seconds.